Okay, so let's see. This is going to be torque is I alpha. Torque is equal to I alpha, right? Notice that we've got a thin ring and a diameter, right? So the radius is 0.730 over 2 is 0.365 meters, right? And so this is a thin ring, right? So it's mr squared, and m is 16, and r is 0.365. So let's figure this out, right? So 16 times 0.365 squared is 2.1316. So ultimately that's kilogram meters squared, right? And then alpha looks a little tricky, right? I got to figure this out. Theta, omega initial, omega final, alpha and t, right? So alpha is going to come from kinematics, right? Let's see, from rest, so 0 in 8.1 seconds, 8.1. The final is 1120 times 2 pi over 60, right? Because we're going to turn that into radians per second, of course, right? And then I guess this one is just omega final is omega initial plus alpha t, right? So 1120 2 pi's over 60. That's converting RPMs to radians per second, right? Is 0 plus alpha times 8.1. Okay, are we ready for this greatness? 1120 times 2 pi divided by 60. I need like a button that just does that. Okay, and then divide that by 8.1. And I get 14.4797, etc., etc. 97 radians per second squared. So 14.4797. That's a 4. 4. This is also a 4. So hard to tell 4s these days. Okay, it's just this number here, right? Okay, and then we got to find the torque, and then we're done, right? So I'm going to multiply that number, the 2.1316, times this number, and I get 30.865 meter newtons. Ta-da!